Good morning. Over the next few hours I'm going to show how fairly straightforward it is to build a mobile app. Now this is a multi-tiered app, so it gets data from a server. It's on an iPhone, but this is a multi-platform C++ app. So we can put it on iPhone, Android, Windows desktop, Linux desktop, Mac desktop. It's like very easy to deploy on multi-platforms. And really I want to show how unintimidating and straightforward this is. I mean, it's not an inconsequential amount of work, but obviously if I can do it in 2 days, it's not that killer. Now I'm skipping to the end. I've already done the video, recorded all the screen. It's 20 hours of video, and then I compress it down to 3. And so we've got the app here all ready to go. This is live feed from my server. So it reaches out, and there we go. This is an app, and the point of this app is it's a transit app. It allows you to see where the buses are in your area. And the point of this app is not for navigating a transit system, which is what a lot of apps for transit do. This app is to help you figure out where the heck your bus is, because a lot of people, that's really, you see them leaning out onto the street and going, where's my bus? Or my train, or whatever it is. And so in this particular case, we've got no buses in my vicinity, but we can see here, we can click on a stop, and it shows you that the bus 327 is coming in 6 minutes, and then it's coming again in 36 minutes, and it'll be here in 66 minutes, and each one of these rows shows you, for any given stop, the next 90 minutes of activity. And you can see down in this area, there's a major transit hub, not too far from me, a few hundred meters away. And, well, we could scroll up and we can see it's 297 meters is where a lot of these buses are starting. And oh, there's a bus 30 that's just popped in off the side here. So if we click here, you can see that bus 30 is expected in 1 minute. And here it comes. And then we can click here and see that bus 30 is expected in 2 minutes at a further stop. And 106 left 3 minutes ago. Bus 4 left 4 minutes ago. So it's all pretty straightforward, and I hope you enjoy watching this get built. Anyway, what we're going to do is we're going to have stops, and this is a very crude representation of the GUI. We're going to have stops, and the idea is you put your stop right here in the center of the radar, so you'd have your stop right here, and with your stop number, and then you would be able to see the buses as they approach or go around your stop. You'll see them animated here with little labels labeling what stop it is and what bus route it is. Then down here will be the list of nearby stops, the closest stop being, of course, at the top. And you'll have right here a series of times. The bus 327 will be here in 8 minutes, and bus 4 will be here in 5 minutes, and bus 327 will be here in 35 minutes, because it comes every whatever, and it'll basically show you the next 90 minutes of buses here. And you can click here, bring up basically another table view. This will be like scrollable up and down. And it will show you the details of what buses are coming to that stop, like row after row of the buses with a bit more detail, sort of a bit more verbose. So your bus will be here in 8 minutes. And then we'll even show you what buses were there just a minute or two ago. We'll maybe show the last 5 minutes of buses, and then that way you can see if you just missed your bus. Now, what we're using here is a data feed from the Edmonton Transit System, but this is a fairly worldwide standard, so it's actually available for many transit systems, and Google originally called it the Google Transit Feed Specification, GTFS, but I believe they've now just renamed it the General Transit Feed Specification. And so from my local place, I get gtfs.zip, and this file here has their scheduling data, and they seem to change that. I've sort of watched it a little while, and I think they change it about once a month maybe. I don't know, it's not that often. And this effectively was what you'd find. You'd need this data if you were to produce like those paper schedules or whatever. It's the bus route, it's where the stops are, it's what times, what buses come, and all that sort of thing. We'll look at that data in a bit. And then there's a thing called a vehicle. They have another file which is live vehicle positions, which is a protocol buffer file. So if you're familiar with JSON, you could just think of JSON but turned into binary. And it means that the data coming out of here is about 10K. It's not very big, and this is a feed of the live positions of a certain number of vehicles, not all, but quite a few. I presume some transport systems would have a very comprehensive GPS feed like that, but here there's quite a few routes that are missing. So you'll find a certain portion of the buses circling around the city have that, and it's great because then you've got something that reflects reality a little more closely. And as I say, this is updated about once a minute. Now we're going to import these two data streams. This one we're going to use Python and import that. It's pretty straightforward. And then I'm going to import this in C++ with the protocol buffers. I'll talk about that, why I'm going to probably use C++ here. I might use Python, I don't know, but probably use C++. And this data here, it just screams relational. So I'm not going to use Redis. I'm going to use MariaDB, which is a variant of MySQL. So a very straightforward relational database. That data will just feed in. Then we're going to have a REST type interface. I'm going to do this in PHP, and this will just feed out a sort of compendium of the interesting bits of information based on our latitude and longitude. So our mobile app will say where it is, and then this will give us nearby stops and arrivals and near buses that we care about, as opposed to the entire pile of information, which is fairly comprehensive. So it'll feed that out into a structure. We're going to have a C data, class data, a class of bus, class of stop. The stop will have a subclass of arrivals. That all, I think, sort of speaks for itself. Then we're going to have a C location class, which, well, figures out where we are and feeds that to the data, so it processes that, which then will produce our screen. And we're going to have just really one scene, which is the radar scene. Later on the app, I might have a version 2 or 3 or 4 or whatever that has more scenes, but we're going to put it all on this one scene here. So very straightforward. Now we'll just do a quickie overview of the data that we're being fed up here. We'll of course go into this in a bit more detail as we dig into the application itself and build it. Here's a little boilerplate. This is what's found in the GTFS.zip, by the way. And this is some boilerplate, pretty irrelevant. We're not going to actually use it. Another file here is calendar dates. It has interesting information. I'm not going to use it. Then there is another file here called routes, which appears to be very useful because it has the has the route names and stuff. But the route names, actually, there's better route names to be found elsewhere. So I'm not going to use routes. Then we have trips. Trips we're going to use a little bit. Here's a binary representation of the days of the week that this bus is operating. They also have a duplicate of that, which is Sunday. But I'm going to use this binary representation, and as you can see, the last day of the week here is labeled with a 1. Here's a bus that operates on weekdays, and so there's the first 5 days with a 1. So, as I say, it's a binary representation of what day of the week it operates. We're going to combine that with a very important piece of information called the trip ID, and that basically reflects a trip. The bus starts at one end of the route, goes circling around the route, and one route, sort of one orbit of its route, will be a trip. And so the same bus might be going round and round and round, and each time it goes around it'll change trips, but this helps figure out the two. And so we'll go with that. And then we'll have stops. Stops is, in a weird way, one of the most critical files in this entire system, because almost all of our data is going to be based around stops or have some very sort of good relationship with stops. This is the stop ID you find on the sign. It's unique to each stop. Then the stop has a little name sort of describing it, and the big important one, of course, is the latitude and longitude. So we'll have an ID, sort of a descriptive name, and the latitude, longitude for every stop. Then we have stop times, which is really, here's the stop, and here, this bus here with its nice description, and this is a description we're going to keep. This is better than the one in the routes.txt. So this bus here on this trip, as I say, trip ID is very important. It's going to arrive at this time, depart at this time. So and of course we know the latitude and longitude of this stop, so we can say at this point in time this bus is here. But we're going to reorganize this data so that we say a slightly different thing, which is we're going to look at this from a motions point of view. And we're going to say this bus here is going to depart this stop at this time and arrive at this stop at this time. So we now know if this bus here, looking at the schedule, it takes 1 minute to go from this location to this location. So one can make the presumption that 30 seconds after this time, so 7:04 and 30 seconds, it's halfway between here and here. So if we know the latitude and longitude of this, which we do, we know the latitude and longitude of this, we can make an assumption that the bus is in between these two stops. And while the assumption is potentially incorrect, it's better than nothing, and that's going to be the information we provide when we don't have the nice GPS data that the transit system sometimes feeds, but they don't always feed for all routes. For instance, the bus around the corner from me, they do not ever feed the GPS data for that. So the only way you can draw that bus on the map is using this sort of denormalized, restructured data that we're going to do. So we're going to keep this table so that we know arrivals and departures, and then I'm going to make a variation of this table, which will be the, as I say, the motions. And it's going to be allowing us to just put in a time and then get a greater than, less than, equal to, and be able to figure out where on the world that bus might be. Anyway, very straightforward. And then over here, transfers, we don't use that. So that's it. It's a very straightforward development. Whenever I begin a project, I like to look at the most difficult parts first, get them out of the way, and then smooth sailing after that. And generally the most challenging part of this transit app is the protocol buffer format that's used to provide the real-time data from the transit system. And this real-time data is, as I've pointed out, is the real-time feed showing where the location of a bunch of buses are. And they send it out in using a format called protocol buffers. This is a sort of, you can think of it as a binary version of the JSON format. Now that's not technically precise, but as we know with JSON, it's a very wonderfully verbose format, and that verbosity gives us the benefit of being able to eyeball a JSON file and have a fairly good idea of whatever complicated data structure is found within that file. And you can have, of course, very complicated data. You can have arrays of objects and objects or associative arrays of objects. I mean, it's whatever, however you want to format the data is there. But that verbosity gobbles up bandwidth, and when we're dealing with mobile apps like this, where it's regularly asking for data, you typically want to go with a protocol buffer because you want to keep the bandwidth down on people's phones, and you also want to keep the bandwidth demands on your server down. So the protocol buffer format allows for that. Now eventually, right now I'm using JSON to talk to the client, but once I get the data format nailed down, I will also switch to the protocol buffer. But the most important part right now is that the transit data feed is in the protocol buffer format, so we need to interpret that. So now each data feed, once, as I say, you've nailed down the data format, you then have a proto file, and this being a standard, there's a GTFS real-time proto file here for transit systems data feeds, and it, without having to go into it in great detail, just describes the format of the binary data. Now we'll just take a quick look at the binary gobbledygook. And as you can see, some of it's understandable. There's a trip ID, there's a vehicle ID, but then the lat and the long and the timestamp and whatnot, they're just binary gobbledygook, and you don't want to be having to try and figure out how to interpret that. So this proto file, you use it to generate header files, and you can use it to generate Python sort of header/library files, which you then just include or import in your project, and then you don't really have to look into this in any great detail, but it will then produce, it will interpret the binary file. You feed it just the binary data, and it will then hand you out a nice array of objects, or however the data is structured. In this particular case, we're looking for an array of what are called feed entities, which are really the buses or trains. And then here's the C++ file, header file that's been exported, and it too, again, is just allowing it to generate a series of classes and whatnot. The most important class is the feed entity. Now, in theory, this format has all kinds of interesting things about buses that are late and having medical emergencies and police emergencies and whatnot, although the transit system here doesn't seem to use any of that kind of data. But it's there. If your transit system's better than the one I'm working with, and I wouldn't be surprised if this one starts to expand their data. But anyway, this allows this proto file to be interpreted and included in our code because, as I say, we don't want to try and manually interpret that binary data. And eventually, I'm going to turn my own data feed into a protocol buffer feed, and which is the reason why, in this particular case, I'm going to use C++ for dealing with the protocol buffers on the desk or on the server end, and I might use also Python, might do it both ways. The C++ will be more of an experiment because, of course, the client is in C++, and so at some point in time I'm going to have to interpret data using protocol buffer data using C++, even though the server is mostly going to be in Python and PHP. We begin with a creation of the Cocos2dx basic file, and then we just will open it up and compile it. Of course, we had to change the permissions where I created it from the command line. And while it's compiling in the background, we'll grab the GTFS data feed. We'll put this into a web directory because we're going to eventually make this into a web page, but for now we'll have the data feed come in through the web, and we'll also put the images in the web that we use in both the web and the application. Now we're going to be needing to do some imports eventually, but now that we've got this the application compiled, it takes a while to compile it for the first time, we want to resize everything on a desktop app because we're going to develop in the desktop app primarily and then periodically check to make sure we've got everything working in mobile. That's one of the great advantages of Cocos2dx. It allows you to do mobile, iOS, Android, Windows desktop, web, Mac desktop, everything. Anyway, so what we're doing is we're going to go with a 640 pixel wide application, and then we're going to scale that to whatever screen we're on. Now, the iPhone 5S, which is what I've got, is a 640 pixel wide. Some of the newer screens, especially in the Androids, are huge, so we'll eventually have to do a redo where it has different graphics and stuff at higher resolutions because some of these Androids have pixel resolutions greater than that of my desktop, packed into the tiny little pixels of the screen. And so now we're going to grab the vehicle positions. This is a live feed. The GTFS zip, it updates, I don't know, maybe once a month. Basically, it's whenever they change their schedule, whereas the live feed could change more than once a minute. And this is a protocol buffer. And protocol buffer is kind of interesting. It's a binary format for pushing out what effectively would be normally sort of a JSON type data stream, objects, potentially sub-objects, and so on and so forth. And it's quite useful. But so what I just did there was create the C++ file for the class, that structure behind that. Now we've moved over to Adobe Illustrator, and this is where we're going to do the GUI. I like Illustrator because it's not really resolution dependent. You can scale things without them going all weird and pixely. And it's also very sort of object oriented, and so that way we can sort of treat everything as objects, which is really how we're going to see them as graphics in the final product. Now I'm going to put them through Photoshop to turn them into sort of PNGs. I like the PNG export from Photoshop better. Now I used Mathematica back there because I just use that as my calculator. Overkill to use Mathematica, but I could use hand calculator for this. And didn't like my first radar, so I would do it again. And just coming up with a look, we're going to basically, the structure that I want to do with this is I want to have a radar on the top and a list of information below, probably stops initially, and then details about buses and whatnot. In different screens it'll be variations on this, but really it's a radar on the top and then cells scrolling on the bottom containing the layout of the, or containing the sort of more detailed information about arrivals and whatnot. So this icon I'm doing is going to be the stop icon. We'll put the stop ID inside there. Then we'll do the bus icon. This is the transit system here, and as do many transit systems, goes with sort of a blue theme, so I thought why not stay with that. And this icon needs to have a directionality because the buses will actually face in the direction they're potentially heading. So I give this sort of a raindrop kind of look, and now I can't put the bus number into such a small icon, so I'll put sort of a label off to the side, and without making just one gargantuan icon, it'll make for a smaller icon. And by creating such concavities in among the icon, it allows for the icons to overlap and still be visible, as long as there's not a complete overlap. Also, we are going to zoom in and out. Now on the desktop we don't have pinch to zoom, so I'm going to create zoom in and out buttons, plus minus. On the mobile there'll be pinch to zoom, although some people still prefer the plus and minus, so I'll leave it for mobile as well. And pinch to zoom is a little bit of a pain to do, so I'll do that closer to the end. And now Illustrator gives a very, very mathematically perfect look, which I actually don't like, so soon I will give this a sort of a roughened, hand-drawn look, which is sort of nicer, but for now I'll just leave it with the sort of mathematically perfect. And we'll do a little, I think they call this a hot dog menu. Put this up in the corner and it'll bring up. Eventually we'll have some settings and stuff there, but for now I'll just put some about text, and then here's the roughening. The roughening, if you get the settings right, can look very much like it's someone who's got a fairly steady hand, but not perfect. That's sort of the art of artlessness. So now we begin putting these things into Photoshop, because Photoshop, as I say, is a good place to export the final imagery, the PNGs that will actually go into the application. And I prefer in Coco StudioX, of course, to import PNGs, and then where these files are very, very simplistic in their coloring and gradients and whatnot, they compress very, very well as PNGs. And PNGs have the advantage of being transparent in the background. If I'd used JPEGs, it wouldn't be very efficient. Some of these drop shadows might do better as a JPEG, but for the most part these will be very small as PNGs, and the transparency is nice. And then, as I just discovered here, if you try and cut off a roughened object, it doesn't actually keep the same roughening. The roughening changes, so I'll just have to redo the roughening, or redo this sort of edge, I don't know what you would want to call that, sort of a designated area. I have to do that in Photoshop. And then we're doing green for a selected cell. Now, the theme I'm going with is intense things, are buttons and menus and whatnot, and things that are a bit more pastel are kind of secondary. They're either a total background, and eventually I'll do the details as a pastel because it's kind of a second tier functionality. It's not something that needs to be in your face. Whereas, for instance, the close button that you see in the right, that'll be used for closing the details, and that is primary functionality, so it gets a bold near primary color, as do the plus and minus and the menu buttons. Now I need to center the bus icon so that it will rotate about that point, and you could set an anchor point that would be the point that would rotate around, or I can just put it very simplistically in the center of a square. area. Being a PNG, the larger graphic doesn't really use that much extra space, and then the memory in the program isn't that big to have a large PNG like that, because we're not going to have that many sprites. If this was a game with tons and tons and tons of sprites, first I'd use a sprite sheet, and second I would not waste space like that. And which that kind of space is also memory. But we're not pushing Cocos 2DX to its limits by any stretch, nor will we be pushing the application, or the mobile devices to their limits. So I'm not really worried about inefficiencies, in that they keep things simplistic. And that's one of the big trade-offs I'm going to do here. I'm going to do a lot of simplistic programming, where I could do a more fancy program, but so here's we're just taking all the hello world out, replacing it with the radar scene. Take out all their example graphics and icons and menus and stuff. That's all going out. And I'm also just getting rid of their boilerplate, simplifying their boilerplate, taking out their comments. It's a good place to start. The basic format that they set up is pretty good. And working top to bottom, we'll do the header, we'll do the radar, we'll do the zoom buttons, and then we'll do the table view at the bottom. And so the header, which is never really going to be altered, it just is a locally scoped variable. We don't need to make any references to the header in the future. It doesn't move up and down or change, so there's no reason for the rest of the program to have access to that variable. Whereas the radar, it needs to be a member variable, because we are going to be regularly referencing it. And the zoom in, zoom buttons, they don't completely need to be referenced as member variables. So what we'll do is we'll create a tag for those. And it's a very useful thing in Cocos 2DX. You can set the tag for just about any object on the screen, and then later on you can ask things what their tag is, or ask for things by their tag name. It's quite a useful feature. Kind of, I could also do it as a member variable, and that'd be another way to do it. But I find the get tag is cleaner. You don't end up with 200 member variables, although then you do have to create sort of quasi-global defines, and I mean, it's trading one kind of globality, if you want to call it, for another globality. And I don't really which would be arguably cleaner. But now I try not to use too many magic variables or magic numbers, but when you're laying things out, I find aesthetics can exceed mathematics, and you kind of need to use some magic numbers when I'm moving things around. Now I don't like them too much, because this is going to go on multiple platforms, and I don't want anything that's a magic number on a different platform. So there we go. So I've set the tags on the various items, and that will allow me to reach back in and grab those items. And here is the listener. Listeners on Cocos 2DX, they work okay. The only thing is, I don't know whether I'm doing it wrong or the code behind it is squirrely, but I find as you create more and more complex listeners, they start going weird. So it's one of these things where you start paying, I don't know if you want to call it a technical debt, but the complexity of a program becomes higher and higher, and at a certain point you've got two options. The program becomes spaghetti, or you refactor. And my general theory on this is I like to try and keep it as simple as possible, but then as the spaghetti starts showing up, I refactor. And I'm happy to go the other way of spaghetti first and then refactoring, rather than trying to anticipate the refactoring too much, and then you end up with a kind of a spaghetti of objects when you were trying to avoid a spaghetti of code. So I don't like thousands of objects that were there just to simplify things that may not have need really that much simplification. Although, for instance, this radar that I've created, it's a graphic here, it's going to be referred to a lot within the scene, and I really think that when version 2 of this program is made, that the radar is going to end up in its own object, so that most of its functionality, things like the listener, will end up being abstracted. And while that might seem good, again, having multiple listeners hiding away in different objects can cause a different kind of complexity, because the Cocos 2DX is not too happy with all that. So here's where we're getting the tags, and we're comparing it during listener clicks, and as you can see, that allows us to click on the radar, allows us to click on the zoom buttons and know who's being clicked on. So now the table view is an extension. I always think of things that are extensions in Cocos 2DX as something that they didn't put into the core, and I always almost translate that in my head as experimental, in that they're kind of beta. I find things, anything in the extensions tends to be more beta than core. And so the table view, it's a pretty straightforward table view. It's like many other table views and many other GUIs. You need one function that returns the size of the table cells. You need a function for when a table cell has been clicked on. You need a table cell, or you need a function for how many cells there are in your data source, that sort of thing. So this is the one that is fired off when someone clicks on a table cell. This is where we pull a cell out of memory, and if there isn't one, we create one. Very standard memory efficient system for tables these days, although I'm creating here a class for the table cell, and I'm not initially going to put anything in it. Like, this class is really just going to be used as a kind of placeholder. Eventually, after I get a lot of the code inside the radar scene, at some point in the future, I will pull the code out and push it off to that radar cell. Probably have to create a few different types of radar cells, but there'll be the radar cell, which will abstract the code. But as I say, right now I'm going to put it in the simple place. It'll slowly spaghettiify, and then we'll abstract it. And I find it just makes coding faster to do it that way. Refactoring this kind of stuff is so fast. I mean, maybe in the days when a compile took forever, it wasn't as easy, but compiles are so fast now. So here we are. We're just setting up the background cell so that the cell has a look. It's using that PNG we created. The table view, of course, is going to be a member variable because it will be referred to a lot. And here's where we set the size to the at 640, which is going to be everywhere. At some point, as I say, in the future, I'll end up doing a higher resolution set of graphics so that the 640 won't be the firm, and it'll adapt to whatever size screen you have. But for now, I'm just going to say 640 and then stretch everything to fit. 640 is pretty high resolution. Maybe someone with an incredible phone would go, wow, this is blurry or pixely or whatever, but I don't really think so yet. I just turned off the warnings within Cocos 2DX because I don't want, while that's compiling, Cocos 2DX itself has a lot of stupid little warnings, depreciated functions, casts that are weird for them, and that's not my code, so I can't really worry about their warnings. And I've got a few virtual overrides here that I didn't quite get the parameters right, but there we go. Now everything's working. And so we're going to jump out for a moment. We're going to go to the Python where we import the GTSF FS files from the. So here's the roots. As you can see, pretty straightforward. We grab their header file or headers. I might as well use their headers as the variable names. And we're going to start preparing to stuff this into a database. Now I was debating between MariaDB, or the MySQL improvement, and Redis, and I decided on Maria for the simple reason that this data largely goes in one way. Like, the GTFS data is imported once, maybe a month. It's not being frequently updated, and it really, I mean, obviously if it's coming out of a CSV file, it's going to be very, very relational. I mean, that's rows and columns. It fits that profile very well. Now, eventually, I might do either a memcached or a Redis database for the moving things. So here we're just creating the bus radar permissions, and as you can see, I used a stupid password. I don't want to use a actual password on something I'm sending off to YouTube. And so there, I didn't click on the right things before. So now it is able to open a connection and get ready to export. So here we clear out the roots, and then we just do a very simple insert. There's only two columns in this particular table, pretty straightforward. We run it, and there they are. They're in the thing. Python's beautifully simple. And then we're really going to do the same thing for each one of the other CSV files. But yeah, so it's we've got stop times, we've got trips, and then I'm going to create a thing called motions, because after I thought about the data for a while, I realized I want to know not where buses are. I need to know where buses are. I need to be able to interpolate, and I'm going to need to create a new table of my own out of their data that gives me a bit easier way to say, okay, I've got a time, which trip is it on, sort of thing, or which segment of a route is it on. And I could do very complicated SQL, or I could do very fast, simple SQL, where it's greater than, less than, work. Anyway, so here we have op days. Op days are basically what days are operational. They use a binary representation of 1 for it's operational, 0 it's not, and this allows us to figure out if a route is functioning on any given day. And that's actually quite important, because now they break it up into weekdays and weekends for the most part, or Saturdays and Sundays, but by sticking with their binary interpretation, I'm able to potentially adapt them using say a schedule for Wednesdays only or something. Now stops, they only, out of the possible rows in the thing, they only use really 4 of them. And so pretty straightforward, the ID of the stop, its name, and where it is. So we can run that. Again, it's not a very big table. There's not that many stops. And there we go. Nicely imported into the database. It's very, very simple. So now we're going to do a, I think, overly glamorously named RESTful interface, where we are going to ask the database various questions about, basically we're going to give it a Latin long, and it's going to give us the thing. And I'm putting this into my virtual host at the top, because I'm going to need to refer to it by IP, in that my iPhone can't really use a hosts file, and radar test can't be put into an iPhone. So yeah, this is. And then I realized I forgot which version of Apache I was using, because I switch back and forth between 2.2 and 2.4, and required all granted is the 2.4. It's the newer thing, and it doesn't really give very good errors that you're using depreciated about allow all and all that stuff. Anyway, so here we have PHP, very straightforward, keeping the queries very simple. I love pushing, sometimes it's fun to push SQL with crazy 8 million character queries that have 12 inner joins and 12 havings and whatnot. It can be very satisfying, but then you've created some of the least maintainable, understandable queries and code humanly possible. So in this kind of database, I'm going to denormalize it. And because of course there's not a lot of inputs going into this database. And so some denormalization won't be that terribly painful. And there it is. Data goes flying out. There's all the stops. Now we don't want all the stops. We only want the closest stops. So we're going to eventually get it so we have a latitude and longitude coming in. Right now we're not going to have that coming in because we don't have that built into the app. So I'm just going to put my address in. If no request comes in, it's going to return my address. Excuse my cold. And And then we need a function, a haversign function, which I'm just going to paste right in here, and it basically gives you the distance between 2 points on a globe. And by adding that to our SQL, we add the Latin long, and we just say, give us the haversign distance. Then we sort by that distance. And then we limit to the nearest 50 stops. And that's it. So very, very fast. There's not that many stops. The haversign is perfectly efficient. I don't know what my, if you go back to if you ran that query and timed it, you'd probably get milliseconds, 5, 12 milliseconds or something for a request. Not very fast, or not very slow. So now we need to create a CData class. This is going to be where all communications with the server, basically that positions.php, is going to happen. Now, eventually we're going to gamify this and make it sort of cool to use, but we're going for a minimally viable product now, so let's make this just happen. So we're going to have a C stop, a C data, a C bus. Eventually we'll have a C arrival, and those are the sort of fundamental data classes. Now we'll just store what we've got working in Git. I like putting things into Git throughout the day because any code you might delete or move, you can go back to if you realize that you've deleted some incredible genius a few hours ago. Better than Control-Zing your way back to your code. And I like the JSON 11 library. It's pretty good. They all have their pros and cons, and this one for me has the most pros. It works cleanly. It works in a almost Pythonic way, as opposed to a horrible, complicated 1973 C way that I find a lot of these other libraries work. And so each of the C stop, C bus, and eventually C arrivals classes will have a member function that when you initialize it, you put in the JSON. And the C data we're going to do as a singleton. Some people don't like their singletons, but there's only ever going to be one C data class talking to the server. We're not going to have multiple connections simultaneously, so a singleton works well here, especially when we have a callback. So an asynchronous callback works well if you don't have to worry about instantiating and uninstantiating and whatnot a class. It just creates once. The networking within Cocos2dx is very simplistic, works nicely. So here's our singleton, and it's a straightforward singleton. If it doesn't exist, create it. If it does exist, return it. And requests with the Cocos2dx, they're fairly straightforward and clean. We're going to be posting data to the positions. Of course, we have to send it a Latin long, which is eventually going to be there, so we won't do that yet because we don't have anything to post, but then it's pretty straightforward. You give it the callback, and then you say fire off the request, and it's good. Good to go. And look, they use singletons too. And so and then the data comes back, and what I'm typing here is a comment about the fact that the iPhone doesn't like talking to non-secure websites. You need to put an exception in. The final site that this will be hosted on will be, I'll get a cert for that, and it'll be HTTPS, and all will be happy, but my internal network, I'm not going to do that. I'm not going to set it up on my router and the whatnot to try and get that all set up. It would be a nightmare. And so now we go back here and let's just finish off importing some more data. Now stop times is a pain. It's got about 1.5 million rows, so importing from it is a pain. So I'm putting a counter in here so that I can just limit the imports while we're working on it, and don't need the counter for any other functionality other than just simply a cutoff after it's imported. If, well, in this case 100 rows, it'll just stop. So now, there it is. We've got the data that can finish compiling, so the data callback happens, but it doesn't happen on the iPhone, so we need to go in and make some changes. If the data fails. Now this failure here, I've just got cout for an error. I really need to do something a little more impressive than cout. That would be some kind of pop-up or something if the person's phone was unable to connect. And of course with mobile, data connections aren't 100% reliable. They can go weird and off and not work all the time. Or you just don't even have data. So now, when I ran it on the iPhone, I realized it was in landscape, not portrait, and that went all weird. So I just made sure to fix that. And as you can see, by switching it to landscape, the compile sort of seems to do everything again. So it's slow. So we go back to importing the data. Oh, there it is popping up. And it's looking good. So get rid of the stats. That's just a little frames per second. Well, we're not pushing Cocos very hard, so we're not going to worry about frames per second. Plus, this app would probably look fine 10 frames a second if we did get down that slow. Although the table view might not look that good, so that would be the key. So we need a stop times table, very, very straightforward. But again, we're denormalizing it. The stop times doesn't have a root ID. I'll have to grab that from the trip ID. And the op days is something else that we're making up. Here I am just testing it on the iPad. As you can see, the iPad's shorter, so it doesn't really have much room for the table, but all works. It's scaling properly. Circular things are still circular. And that's how it's going to work on, well, pretty well every phone. It would be a disaster if someone had a square screen on their phone, though they'd only get the radar. So here we are asking the positions data, and it's good. And so now we begin parsing the JSON. So one thing I really wish this had was like the equivalent to the PHP var dump, where you could just say, take the data and show me its objects and sub-objects and whatnot. It doesn't work that way, so that's what stepping through the code and debugging it is for. Then we're going to, pretty straightforward, we're going to take in each one of the stops from the JSON and push that JSON sub-object off to the stop for it to interpret. And here it is where it'll interpret the code. Stops aren't very complicated. Latitude, longitude, name, and an ID. And we'll just jam those into the member variables. I'm using the stop almost as a structure with a function. And I put this little printf here so that I have a place to put a breakpoint. And the stops aren't coming in. So this is where the dump would be nice. And as you can see, it has interpreted the stops as a map for some reason. It hasn't interpreted them as a string. And that is not perfect. And the reason it's doing it as a string, it's interpreting it as a string-based map. String, that's the key. And so there, we can just turn it into an array, because I'm asking for an array, and there we go. Stops come in, all is happy. And you have to ask for object items out of the JSON if you want objects. And then say, here's a geostuff library that I've sort of assembled from a bunch of stuff. And what it does is it gives us a lot of ways to work with lats and longs. So you can say, what's the distance between this lat long, what's the bearing between this lat long, that sort of stuff works brilliantly. And I use it in a variety of code. So I just paste it in here. So now we need to round out actually getting the data. We've got a list of stops. And this is the update loop. This is the main game loop within the radar scene, and it's going to be drawing the stops, drawing the buses, updating the data every single loop. As I say, that's 30 times a second, but the system works. I mean, this is not a difficult bit of code to get working. Now, what I'm doing here is I'm creating a map of sprites, stop sprites, and I'll do bus sprites. And the reason I do a map, these are sprites that are active. It's kind of like the way the DQ cells work with a table view, where you DQ a cell, or you DQ a sprite and then use it, although it's a little bit different that we don't reuse sprites. But as sprites appear and disappear, because as you move, buses move into the world and out of the world, we don't want to be creating a new sprite every scene or whatever, and so we need to have a list of sprites that we can pull from. And if we'll say for this bus, do we have the sprite? If we don't have the sprite, then we need to create it. And then that way we have a sprite for every bus and a label for the sprite and so on and so forth. And this is the little label, because the sprite is going to rotate, but the label is not. Now, you'll notice that I was using a radar sprite. We're not using a sprite. Radar sprite inherits from sprite, but it has one other little feature, which is an in-play member variable, and that allows us to figure out which sprites have just been updated in the last loop and which ones weren't, and the ones that weren't we get rid of. So there's probably a dozen different ways to do that, one of which would be to create a stop sprite class, which would only be derived from the list of stops, but I didn't go that way. So here's where we're updating the x and y, and based on the Latin long, as relevant to our present position. And that gives us the ability to, well, have things on a radar. And that'll be updated every single game loop, so 30 times a second. And so the latitude is going to be stored in the data. We're not going to store that on the radar scene. And then we need to be able to set the latitude and longitude within the data thing. So there's just a quickie setter. And then the process data, we're going to be doing moving the buses, moving the stops, moving so on and so forth. This would fail if there were 10,000 buses and 10,000 stops, in that it probably would be too much work to do every game loop, but with so few stops and so few buses, it's actually perfectly efficient. The program can handle it. And one thing that would be good is if we actually had the update loop running. And also, it would be good if we had the sprites actually moving around on the screen. So we set their positions. Now the sprites are the lat to x function is making it thousands of pixels apart, and so there we go. We just divide it by 30, get that down to a size that is nice, change the color of the label to black so they're visible, and here I am looking at an anchor point issue. Try different anchor points. Again, magic numbers in most code are sort of bad, but in some cases it's based on aesthetics as opposed to anything mathematical, and it only applies to the individual sprite at that point. If I'm just nudging something in any given direction, I'm not unhappy using a magic number right there, because the scope is so tight. I mean, if I'm nudging the zoom button as I did before and nudging it around, it's only the zoom button. No one else ever need know about that. And, well, I find actually putting it into a define is actually it just increases complexity, and then you might end up with, if you change your mind on the whole way you do it, you might end up with a bunch of defines that have no connections and so on and so forth. It's an aesthetics. Aesthetics, I like magic numbers. I'm okay with it. I avoid them, but I'm okay with it. So here I am packing the bus labels into there. Now, there's a couple of problems, one of which is the XY, or the y-axis is flipped. So I need to, I already flipped that, and then everything needs to be offset by half a radar. So there we go. And bus stop 2765 is the one that's closest to my house. It's about 180 meters from where I live. So now we're going to set the ability to zoom in and out, and that's just going to change that range multiplier. So we're going to, that 30 that we set, that we were dividing the thing by, we're going to set as a range. I could call it zoom, but radars I always think of as range, setting the range on a radar versus the zoom on a radar. Even though I'm calling it zoom in and out as a function. Zoom is the verb, range is the variable, and so by putting range there, we can then, swapping plus and minus, dumb it down a little bit, and there we go. We can zoom in and out with buttons. Now eventually we're going to do push to zoom, or pinch to zoom, sorry, so that'll be much better. But so here we are creating the various stops, and this is where we need to put the in play, where we're going to be able to delete stops that are going out of play. There's definitely some better ways I could do this, but I'm perfectly happy with this. One bit of horribleness is down here at the bottom, where you can't iterate and delete, or you can't, while you're iterating through a map, you can't delete from that map. At least it's not straightforward. You have to go to the old iterator style to do that. I don't like the old iterator style with the begins and ends, and I avoid it where possible. And so here I'm just creating a artificial movement, because of course I'm not moving and I'm not actually getting location data yet, so this allows us just to see things moving as if we were pretty well screaming across the city. So now we need the time. And so we're getting this from the server, and I want everything to be based on the actual time the server thinks it is, and I'm using seconds. Seconds, what second it is today. I don't want to be going in and out of date functions. Everything's pretty well seconds. We don't need a finer resolution. We could actually probably do minutes, but seconds is fine. And here is where we turn the weekday back there into a binary. So there we go. I didn't get the plus equals. So there we go. So right now it's 52,000 seconds into the day, which makes about sense. It's 2:30 in the afternoon. And so we store the server time on the device. And then this way we're not asking the device its time as the sort of be all and end all. We will ask the device its time, then we'll compare it to the server time, and then we'll work only with deltas of the two. And that way the device could be, doesn't matter. Now most devices are going to be cell phones, and they're going to have very accurate times and probably in full agreement with the server. But probably is not where I want to be. I want to just not care what the time is on the device, in that I will only care about changes in time. So here we are recording the time on the device at the time of the request, which in theory could be the exact same time as the server, but I'm not going to care. So now and then that time now on from the device is going to be we're going to do a modulus against the update interval. Now right now I'm setting the update interval for every 10 seconds, but on the live app it'll be about once a minute. It'll ask for new data. And it'll be a prime number, because we want the least, we don't want a bunch, and it'll be a random prime number in the ballpark of a minute, because we don't want a whole bunch of devices all asking for requests in lockstep if they all happen to ask in the same second. So now as you can see, it's not deleting the icons, so we need to actually delete the icons. And it's still not deleting the icons. That's because we weren't deleting them from the radar. And then we have to do a parameter true for a cleanup. And there we go. The icons are appearing and disappearing as they should. Because remember, we're only showing the nearest 50 stops. And so now let's get some locations. Now for locations on an iPhone, because this is initially going to be developed for the iPhone, you have to access the API with Swift or with Objective-C. I'm a little more comfortable with Objective-C, although Swift is fine. And so what I'm going to do is I'm going to wrap the Objective-C entirely in C++. So the rest of the application will talk to a C location class. And in the case of the C location, it within the description of the C++ C location class, I'm also going to have buried in there the Objective-C, but it will be entirely abstracted so that only the C location class will be able to ask anything Objective-C-like. But this then can be conditionally, the if-def conditionals can be put in there to get rid of the Objective-C and replace it with what I'm going to end up using in the Android, because I'll do an Android version of this and it will have the Objective-C. Or it won't have Objective-C, of course. And it'll reach out to the Java API with a nice little wrapper and blah, blah, blah. And that will be, again, it'll just use the C location. The rest of the program will use the C location class and not know the better, or know any different. So the Objective-C is entirely buried here. Now, I'm going to use two singletons. I could put an Objective-C, a pointer to the Objective-C inside the C location header, but I want to just keep it completely isolated inside the C location mm file, and it has to be mm, of course, if there's any Objective-C in there. Otherwise you get very strange errors. One of the errors is not, this needs to be an mm file. You get some weird crap, I think, about NS strings or something. And I'm keeping everything in here, so there'll be one singleton for the C location class itself, because again, there's only going to be one instance of it ever, so singleton is very much applicable. And the other one is going to be a singleton pointing to the location manager, which will be accessing the API. And that one's a little more debatable as to which way I'd go, but for me, I'm going to do that. Now there's one little conditional I need to put in here, and that is you have to actually make a request for authorization. That's that little pop-up that comes up on the iPhone saying, can I please have access to the location? And that doesn't compile for the desktop, so it's a iPhone-only compilation. But if you don't put that there, it won't make the request, and you will just mysteriously not get location data. You would think, I think the old way it worked was when you started talking, when you first made a request for location data, if you didn't have access, it then popped up at that point. And some people wanted to have an isolated function for that. So anyway, and then of course I should have a thing saying if someone doesn't choose to give that access, that the application really isn't going to work for them, because this is very much a geo-based application. And we're also going to be looking for headings, because we want a compass heading so that we can put that, which way is the person facing, on the pop-up, or not on the radar, sorry. And with this heading, we're going to have to play some games, because headings are very twitchy. And so what you have is you need to sort of, what's the mathematical term for it? It's averaging over time or something. I do a lot of finance math, and for some reason the word time series just wants to keep popping in my head. But anyway, it's going to be where you do heading. The old heading is going to be averaged out effectively by putting it into a vector that is longer than the short heading, which is in the new heading, which is in a short vector. Then you add the two vectors together, figure out which way that's pointing, and it will kind of average out the heading. It'll smooth it out, because it's twitchy, not as in twitching from 90 degrees to 10 degrees, but it's just twitches back and forth a handful of degrees, and this twitchiness will then get smoothed out. It means if you swivel around really quickly, it'll take a moment to catch up, but the twitchiness is tacky, it just doesn't look good. So now, another little feature of the architecture of this is I'm not using callbacks in the way of asking. I could do this as a location where you say, okay, when the location updates, it calls back into, say, the radar scene to tell it that there's been an update. But that could cause weird race states. It could interrupt in the middle of cycling through some kind of loop where you don't want the location changing in the middle of the loop. And what this will allow for is I'm going to go the other way. I'm going to have the update loop ask the location if it's changed. And only then will I act upon it. I don't want to go the other way around. I don't want the location. And so what if I'm asking it 30 times a second if you changed? There's only going to be two things that have the same sort of architecture. It's going to be the C data, have you changed? And it'll be the location, have you changed? And I mean, if there were 1,000 objects where I had to ask that, maybe that would be a sloppy architecture, but I don't want to be getting involved in multi-threaded thinking. I don't want mutexes, I don't want locks, I don't want all that stuff, because that is where crashes are born and really, really hard to debug bugs. There's times for multi-threading, and it works wonderfully, and this, to me, is not a place where the tiny bit of efficiency increase is worth the huge amount of heartache increase. So here we are in the update loop, and we'll be checking, and I love tuples in the latest version of C++, the latest versions, and for some reason, I don't know why, I typed bind here. It's tie, and I just jump from language to language too much and forget these things. I can never remember, for instance, how to find a string within a string, a substring from any given language, because they all use in-string, substring, substr, so on and so forth. So there we go. So now we have the location is basically now working. So we're going to, I'm just trying to figure out how I'm going to do this data updated thing. There's a variety of ways to do it. Use it as a Boolean, a resettable Boolean, or just has the actual lat long change. That's always another possibility from previous lat long. And there we go. So it is a one of the things is, I don't know if you could really see there in that last one, every time the data updated, the table was jerking back to the top. So what we're doing now is before we reload the data, we grab the position, reload the data, and then set the position back. Plus, the very first time, the table can be just weird. It can be right off the bottom of the sort of the table, so like it's scrolled all the way up. And this way it will be now in the right place. And so now we're going to start populating actual data in the table. So we'll put the stop ID in. So the first thing we need to do is get the list of stops. And this would be a perfect example. I don't want the stops list changing in the middle of a table update. So because if this list of stops changed, it could have in length for some reason, and then I'd be referring to indexes that don't exist. And this is why I don't have the sort of callbacks passing this data back. So here we are, just creating little member, I wouldn't call them member, they're just, by referring them to tags, I can create them when the cell is first created, and then update them when the cell was successfully dequeued. If you've done any table cell stuff, the dequeuing is theoretically much more efficient and whatnot. I think with more modern processors and the huge gobs of memory, that unless you're really tight for memory, that dequeuing isn't as critical, unless you've got thousands and thousands of table cells with complicated data in them. But in theory, you don't need to show a table cell that isn't in sight. So it's all very efficient. Now I'm setting a rich class, and the reason is that there's a missing functionality from the rich text class in CocoaStudiX, which is to clear it. And seeing that I'm dequeuing a thing and then reusing it, I need to be able to clear the cell to do that. And I need to access a member variable, a hidden protected or private member variable inside the rich text class, so I had to inherit from it in order to get at it, which is the clear out the text. Maybe I've created some horrific memory leak inside there, and that's the reason I didn't do it, but it didn't show up on my sort of scans or whatever. So the rich text class works fairly straightforward. You just create rich text elements and add them on like it's an array, and they show up. And you can give them different font sizes, colors, whatever. And I want 2 here. This is why I'm not using just a more normal label. I want 2 different kinds. I want the bus route number. I want that to be sort of bold and notable, and then I want the minutes to have a slightly, I'm going to go with a not bold, and then that will sort of distinguish the 2. And put a bullet in there rather than a asterisk. It's probably some keystroke that'll give me a bullet. Don't know what it is. And there we go. So it's one is bold and one's not bold, using the 2 slightly different fonts, and you can see it's perfectly fast, and then it gives you the ability to, at a glance, to see which ones are which. Now later on we're going to color them as well. So if a bus is about, if we've just missed a bus, it'll be red. If it's about to get there, it's green, and it'll be black if it's going to be a while. And so now we need the little details button, and that's going to bring us the details on that stop. And so we need a details layer, and this is where a lot of the UI should eventually go. We're probably going to have a tables layer like this. We're going to end up with a radar layer and so on and so forth. But one of the reasons I'm immediately doing this one, as I say, I like to do these things usually as a refactor, is I know that having 2 tables on the same layer will send Coco's 2DX table whatever. They've got some code in there for handling the scrolling and whatnot, and it will lose its mind. It just doesn't work. I don't know why. Again, maybe I'm doing something wrong, but it's 2 tables, especially when the tables are side by side like these 2 will be, then it doubly loses its mind. So I really need to break them up into separate layers. So we create a whole scene here for the table view, and it's, as you can see, it's pretty well the same. Now it's going to go up and down with the table view, so we need to be able to set the size, and then every time you click on a stop, we need to be able to set the stop, because this is going to be using the stop data. And then, of course, there's all the usual table functions, very basically identical to the other ones. So we're just going to arbitrarily set that to 5, so on and so forth. Nothing too miraculous here. The same DQ of the cell. We're using the same cell type, radar cell. All this should probably be a stop cell. And it will be a stop cell when I abstract this cell out, but for now I'm not doing that. And yeah, nothing too miraculous here. It's the same code, nearly, or I shouldn't say the same code, it's nearly identical code to what we find making the table view work on the main page. So we want it so that when we click on a details button, now this is where it gets a little funky. We need a listener for the details button, but then we don't know what cell the listener is being clicked on. So we're going to have to play a little game where when the cell details are clicked, we then need to wait for the cell to be clicked. So we're going to allow the click to go through, and then we'll say, oh, the details were clicked in this click, and we'll know the difference. Like we'll be able to, we're really catching the details click in 2 places, and this is the kind of example of what I'm talking about, where cells are weird. And if we had abstracted the whole thing, it might have worked a little better, but then the details could know which cell it was associated with, which stop it was associated with. So here we have the details layer being clicked, and nothing. We need to, of course, have a details layer being created, just like the table view, and we're going to create it off to the right, because we're going to have it slide in from the right, and then we're going to have the table view slide off to the left. So it's, of course, the same width as the screen, and then the height is going to be the height is going to be the same height as whatever table we've created. So that was where we use that set size to so it'll be basically the details layer will be the same size as whatever went into whatever size the table is, because and that goes up and down based on what kind of phone we're on, or iPad or whatever. The iPad was very short, and the but then, to make it a little weirder, we don't want the table view to be filling up the entirety. As you can see, we want a little gap on the top. I've nudged it over to the left, so there's some ugly overlap, but that's just so I can see it working. We'll eventually shove it back to the right. And you'll also notice that whenever I move one table, the other table moves at the same time. So that's what I'm talking about, the kind of weirdness that happens. They're both picking up on movements. So then we need to figure out when the table cell was clicked, when the one was selected, we need to know which stop was clicked on. So we go back to the vector, get that, and then we pass that on to the thing, and now we need a little animation. So we just slide them out. We'll do it with a bit of flourish. And you don't really see it in this screen capture, but it does do a nice little bounce. It's pretty. And because the last thing you'd want is just happening instantly and people wouldn't know why something changed. Nice bounce gives them a feedback that something has changed. So now we need a close sprite, which is going to give us the ability to, well, hit close, and this is where we need a callback, because the callback doesn't change the data, it just simply makes the visibility on the screen go, so I'm not worried about a callback causing some kind of erase state or lock, because the program doesn't care which of them is visible, so much as it's an aesthetic thing. Obviously, if you can't see it, you can't click on it, but it's not a data situation. The table on the hidden table will always be updated just as readily, whether it's visible or not. So I'm just doing some little debouncing and stuff here so that you can't click on things twice and move things too far, because you could potentially pile up two animations on top of each other and then the GUI would have gone mad. And that would be terrible. So now we've got it closing. So we're capturing with the listener. The capture works. And that's all looking pretty good. So we just need to do some aesthetic changes here. Figure out who is we're putting in things like how far away the stop is. Just line things up so that it looks pretty. Choose good colors. The stop ID is big, the distance is small. In some ways, this distance is probably the higher priority. Of course, we want an integer distance, not a... People don't need to know what portion of a meter they're away from a stop sign. Plus, I find a lot of these stops are actually slightly out on the road. The lat and long actually doesn't put them up on the sidewalk. It's where the bus stops, not really where the bus stop is, which is not a great way to describe it. But yeah, it's the lat long is not perfect. So obviously, if you're within a few meters of a bus stop, you're at the bus stop, and the sign should be visible. So we don't need to navigate. It's not like a robot's trying to find this bus stop. And now we need to start converting the times as we import them into seconds. So as we import the stop times, this is the one that has like 1.5 million rows. There's a lot of buses making a lot of stops, and a lot of stops around the city. And some of these stops are crazy close to each other. I mean, there are routes with over 200 stops on them. So it adds up. So yeah, so we're also getting a route trip, because I'm denormalizing this, there is no root ID within the stop times, and root IDs are very useful. So I'm getting the trip ID from the trips, which then matches up to a root, and then I can get the root ID for the stop times. So we save that as denormalized data in the stop times database. And so we of course also want the op days. That's some code that we kind of invented, or row, column that we kind of invented. And now this is coming right, so we'll use as much copying and pasting as possible. And so we need to make this insert work rather well. And this insert, as you can see, I've got it still counter limited to 100, just so we can test it. Because there are so many stop times that we don't want to be importing them over and over again, 1.5 million if we can help it. We're going to do it enough times anyway. So, and just a little mistake I made with the forgetting the data type. There we go. There's 100 of them. So now we'll bump that up to 1,000. Import that, and we get 1,000 in the database. Now we'll try 5,000. Same thing. 5,000 imported, 15,000. And now let's we can just potentially do them all. Now, one of the things here is we can do this is a funky little bit of code. I'm not doing this one from memory. And what it does is a very fast way to get the file size roughly of a very large file, or get the line count, without just simply going through and making the file count. Later on we'll use this for some kind of progress meter. It's fast enough with 25,000 rows, but once we start getting out, and also keep in mind we're not indexing this table yet. Once we put the indexes in, that'll slow the inserts down. So that's going to take a minute or two each time we do that import. And we also need now arrivals. Now that we have trips, we can get arrivals, and arrivals are pretty straightforward, except, I shouldn't say they're straightforward, because an arrival is pretty straightforward. It's when does it arrive, when does it depart, and how long. Now, the database doesn't know how long, but we'll calculate that. And then the trip ID. And that'll largely be pulled out of stop times, which also shows that we're inserting more data into the stop times database than we really, or the stop times table than we really need. And arrivals will be a it'll be a member variable of stops. Each stop will have its arrivals. And so now, in order to figure out what arrivals, we need to have a select where in. So we're going to need to figure out what stops we're dealing with, and then we're going to ask for this given day, at this given time, basically from about 5 minutes ago till 90 minutes from now, what stops will be happening at any given stop. That's what arrivals will be happening at any given stop. So you can see that we do the logical and. I'm just trying out various things to make sure my code's the way it's supposed to be. Different base 2 representations of days of the week. And those are the stops, the 50 stops near my house, and then stops that are happening about now. You can see that it's 6:30, and one of the downsides is near my house the stops start running out about now. So I forget what time the bus runs till. I don't take it very much, which is sort of funny for someone making this app. And so we have, so here we have the times, as I say, 5 minutes ago to 90 minutes from now, because it's actually nice to know if you just missed a bus. So I'm just putting that in there, and then we put the in stops. That's compiled from the stops list. Again, that kind of code wouldn't work too well if there were too many stops, but we're only talking 50. Also, a prepared statement doesn't work too well when it's all dynamic, but again, it's a very simple statement, and it's clean. And prepared statements are also great for security, but this code is all being created by itself, times and op days and stuff, so there's no risk of there being some kind of insert attack, SQL injection attack, I mean. And there we go. So we're getting arrivals showing up. And the arrivals are all for any given stop. There's a stop, it's lat long, and now the arrivals. So we need to just save things off to Git again, just in case we start deleting things. It's nice to have that code. Love Git. So simple to use. And now I'm not pushing this off to a repository because, again, this is a tutorial, not a real code base. Well, it kind of is a real code base, but maybe it'll go to a repository in the end. So now we need to bring in the arrivals. We've got our arrivals class that's nearly identical to our stop class. It's all the same kind of functionality. We're using it more as a structure, and now we need to go into the real text or rich text, and we also need to know the difference between. This is where we're finding the difference of code as it moves along. So we'll now put we'll be updating the arrivals. So with the time is getting updated with every go. And now here's where the rich text, our placeholder rich text, gets replaced with actual arrivals. Of course, there's no minutes for some reason. So we need to figure out why. Now, I generally don't like new. I like doing things as, yeah, I think it's time for stop. Had a nice lunch. And so anyway, so here is we need to get that time in. Figure out what is going wrong with the time. Test it on the phone first. And it seems to be updating from the phone a lot. And here's the heading. Fix the heading. And changing how it gets updated headings. And this way, the heading is there's fewer references to a heading. It's cleaner. I was getting an overlap between my Objective-C and my C++. One downside to cramming two functions into one thing. I'm just getting rid of all the crap that the debug version of Cocos2dx puts out. I don't want it filling my debug window with its crap. Quickly modify their library. So now we need a selected cell. Make it, basically we're putting in each cell, we're putting a visible and an invisible version of the background. One background, the selected one being invisible, and the not selected one being visible, and the selected one being invisible. And then if this happens to be the stop that was selected, then we will say it is visible. Swap them around. Not the world's most memory efficient way to do that, but again, we're not working with tons and tons of cells, and I find pushing for that kind of efficiency just complicates the code at this early stage. Again, if I were anticipating millions of cells and bajillions of sprites and lots of math, then I'd be more efficient. So now when the details are selected, I'm just making a few adjustments to the content size. Things are overlapping a little bit there. I also realized I need to move the details button away from the edge of the screen. It was hard to click on the iPhone with it so close to the edge, which then means I need to change the rich text, make it a little narrower. And there we go. Things seem to be happy. Now this is where I ran into a which cell is getting touched. As you can see, I keep clicking on the same cell and it starts telling me a different cell is being touched, and this is the listener going mad. And that is just really, really, really annoying. So for now, I will I realized that the cells were all sort of overlapped incorrectly. So I needed to just move everybody down a little bit, because the cell that was being drawn is not actually the cell. You can draw it offset from the actual cell by quite a bit. And now it's a little happier. And so clicking on an actual cell clicks on the cell you all clicked on, which is, I believe they would call that anticipated behavior. So now this is where we're getting some weird listener stuff, and the best way to describe this bit of code is that it is time to beat the event listening code over the head with a sledgehammer. I don't know who out there watches Top Gear, but this is the sledgehammer treatment. Elegance is not part of this next bit of coding. And basically what's happening is when I click on a cell, it doesn't always tell me that I've clicked on the correct cell. And so I began a fun little game where instead of using their clicked on cell code, I swap it out where I just figure out where in the scroll view that underlay the cells is being clicked, divided by the number of cells, and then create a just a simple index. So effectively the index of the cell being clicked on based on the height of all the cells together, being divided by the number of pixels down. So then we just move all that code out of the cell click, move it up there. I'm generating an index, so it doesn't really need to change too much. And now it's the code as it should be, and it's clicking the way it should be. Whatever weirdness with the listener was going on is now basically gone, because I'm using my own cell clicked code that I conjured up. This is one of the things I love about C++, and that is that regardless of what dead end you might kind of hit, there's always a way to just make it happen. Worst case scenario, you hand code it from scratch. This is why I believe projects in C++ tend to get completed, because they might be slow at the beginning, they might be slow in the middle, and they might be slow at the end, but they were always the same speed. There was no, you can't get there from here. Or the classic, a project is 90% done for 6 months. It just always is progressing towards more done. So now we need a stop that isn't active. As the evening comes, we're now at 10:44 p.m. and sometimes the stops aren't, well, available. I know the buses in my areas don't come anymore at that time of the night, and so we have to mark the stops as not available, so people don't want to click on them and whatnot. That way, at one glance, you can see there's no place to catch a bus nearby, which answers the question that some people might have, which is, can I catch a bus? So this will basically figure out if there's no arrivals. There we go. So those are the X's in my area are the ones that are on 327, and then there's a more busy terminal down to the lower right-hand corner, and it mostly keeps going. Night. Need a little bit more of a faded X. The X was too intense. As I say, pastels are for slightly less important information. So keep this as simple as possible, and then we need a little game where this could swap out in the middle of the day. We don't want a permanent icon because, well, if the buses stop or the buses start coming while you're using the app, we need it to swap that icon out. And so now we need a selected stop icon, and we're going to just put this one behind the existing icons. And the benefit of that is, rather than having a double or triple, or well, actually it'd be quadruple, there'd be selected stop not in use, selected stop with use, and then not selected, and with that's got the arrivals and not selected with arrivals. So rather than having 4 conditions, I'm just going to put the selected stop singular icon. It will then show up behind whatever stop has been selected. And by putting it behind it, it will line up, the glow will overlap, and so we'll just set a nice little glow that we'll put in behind. We don't need any details to that because it's really only going to be an outside glow. There we go. So no matter which one we select, it glows. Make it a bit more obvious, but an orange glow might be good. I think I might switch it to an orange at some point. But it's one of these things, let's just proceed while things are working well. So now we need, I'm just going to just tightening things up a little bit here, because as I said at the beginning, quite often you need things to tighten up to get more screen real estate. So we're going to tighten the zooms up. And now we need to label the buses. Or sorry, label not the buses, label the stops within the stop details. We'll eventually get to buses. It's all about buses. We'll eventually get to buses. So it's the same routine. We're looking at you click the details and it brings up the various stops or the various arrivals that are going to happen at that stop in the next little while. Nothing too terribly difficult, nothing too magical. Just more details on individual buses, because of course most people are concerned about really what bus is coming. They were waiting at a stop. When is my bus coming? It's really what this whole be an alternative name for this whole app. When is my bus coming? And throw another thing in, and seeing that it's 11:30 p.m., I think it's time to wrap up day one. We're going to begin with importing some data and getting it to show what our time is, because we're going to need to know what the difference between the time imported, and we're also going to begin getting the Linux server set up. So we need to know the arrival time and the difference between the arrival time and the, we're going to figure out how many minutes before the thing arrives. So for each arrival, we need to go in, compare it to the timestamp, and get the number of seconds till arrival. And actually, we should maybe, yeah, we'll go with seconds till arrival. Maybe minutes till arrival would be better, but we'll start with seconds till arrival. So we need to figure out, I'm just putting the x equals 0 in there as a placeholder for the break, line break. And so what we're going to do is we're going to look, I'm just looking at the database for a second here, and then we're going to, there we go. So we've got the times coming in, how many minutes it is till arrival, including negative. And we're going to also then need to, let's change this to minutes, because everything's about minutes. We're never going to tell the user how many seconds it is till they arrive. And that'd be a little too specific. So then that way we have so many minutes till arrival, and then we're going to start arranging it so that the color of an arrival is when the arrival's coming in. So we had to do a quickie order because the order wasn't right there. We just ordered by buses, not by the arrival time. And so now we're looking at trip IDs and whatnot, just verifying that we're seeing duplicates here. And this is where it's getting a bit weird. Why is the same bus with the same trip ID being imported multiple times? It's a bit of an import error, I think. So we'll take a look. Or is it an no, it couldn't be an output error because the output is pretty straightforward. So we'll just check the inputs. And we want to sort of get rid of duplicates. That is, I'm seeing that when the bus isn't on a turnaround, sometimes it actually stops at a stop and leaves from that stop at the exact same time, which is kind of irrelevant. And it's resulting in there being a bus being in the same place sort of twice. And when it isn't, like, it's obviously it's not going to be at a stop for 0 time as a time to, well, how to explain it. Having a bus at a 0 time is useless data, basically. Really, we need to just arrive and depart. So let's see if we can get this to unify. That is, like, we're going to combine the various stops that don't work. And as a sort of a break, we're going to set up a Unix machine. And this takes a long time, so we'll be dancing back and forth between setting up a Linux machine in the background and getting it to install, because each install you sort of prod it along to the next step. So we're still there. We've got a little bit better Still, the data is not perfect. You need a little bit more of a... basically what we're doing is we're creating a unique identifier for any given stop. And then if that unique identifier is being hit, we're going to ignore it. Let's separate the unique IDs by little underscore. So there we go. So those are the IDs of duplicate stops. And so now we're just going to isolate this down to stop 327s because we have so much data, or route 327, sorry. We have so much data to go through. It's nice to isolate that down to a single thing. So there's Linux booting up in the background there, and putting that into a virtual machine. I'm not going to set this up this way on the actual server. Things like logging in as root is not really a good idea, but this is a throwaway virtual machine, and I don't want to be typing sudo all the time. So this machine, by the time you watch this video, will have long been deleted, and there will be a proper machine set up properly on a proper server. So we need to compare integers to integers, and there we... And of course, I just said compare an integer number, convert an integer number to an integer number. That was dumb. So there. Now we're only looking at root 327, and this is just me configuring Linux. As I say, I'm going to jump back and forth and back and forth. For the most part, from this point on, if you see me with the terminal window open, I'm doing Linux. I'm not going to really describe too much. Just getting a nice version of CentOS. This is CentOS 7. We're going to be installing PHP 5.6. Should really put 7 on them. Any machine being put out at this point. 7's super fast. And we'll install MariaDB. We'll install the various development libraries that you need to compile the C++ that we're eventually going to compile for the protocol buffers. And then, of course, the protocol buffer stuff, which is actually fairly unpleasant to install. And yeah, so here we are trying to find the appropriate arrival and departure times, and probably one of the easiest ways to get this to come out is, so I'm just putting the code in. You can see that we're getting duplicates, 2 different trips being at the same stop at the same time because the op days are being weird. So there's 2 16s, 2 stop sequence 17s, stop sequence 18s, stuff like that. It's not. Something is wonky. And what I've come to realize is that within the stop times database, they have stops, or they have somehow created garbage routes where the same bus is going around at the same time. They've got 2 buses going around at the same time, and I guarantee the 327s, it's a little tiny bus, they do not have 2 of them going around towing each other around. They are, there's only 1. So for some reason they've got 2 trips that are simultaneous. Maybe there's some internal mechanism that makes sense. But I do not need, like there it is, look, these are the same bus, same operational day, and they don't have to, I guarantee it. And so let's do a little bit more Linux install. It's nice to see that they're installing the Python 3 properly now with CentOS 7. And although I'm putting the pip3 in proper way, because for the most part I use Python 3, but sometimes you have to use Python 2, and it's nice to keep them separate. Plus, if you wipe out Python 2 on CentOS, things like eum stop working, which is only a giant disaster. A lot of dependencies on Python 2, so you have to keep it perfectly intact. I just don't use it much. So here we have, route 327 has multiple trips happening at the same time on the same day. And that makes no sense whatsoever. So in is the wonderful term that I was taught years ago when you're converting a database from one form to another. It's called a conversion effort. And quite clearly, I have to put some effort into converting their database to my thing. So yes, there we go. So 2 separate trips that happen on the same time on the same day. That's just wrong. And if you look at the end of that, there was a block ID which showed that it's even a different bus. Because the block ID in theory indicates a different bus. So I will kill it. Clean up the data and make it so there's only one bus. Now, quite possibly, if there were a scheduled 2 buses that go around at the same time on the same route, I'm about to kill them, but that doesn't really matter from an arrival time point of view, because do you really care if there's 2 buses arriving or 1? All you care is that there's a bus, a number, whatever, coming in 4 minutes. And so there we go. And now we have only 1 bus happening as it should. So there's 1 bus on the weekends, and one bus on Saturdays, 1 bus on weekdays. Go back to Linux, get Maria going in. Standard Maria secure installation, wipe out all the crap. I set the password to stupid password, because that's just, as I say, a temporary server. It's not real. And I installed NumPy out of habit. I'll probably do some data processing on this, but I'm not actually going to be using NumPy in this particular installation, or I shouldn't say in this version of the software. I'll probably do some data analytics at a later point. If I start collecting user data, then I would definitely grab it. Now this is where we have an interesting improvement that they've made to their data. They actually put the direction. So 327 Belgravia is different than 327 Strathcona. And the reason for that difference is that one's heading sort of east, one's heading west. Basically, 1/2 of the route is Belgravia, and 1/2 is Strathcona, because those are the 2 endpoints of the route. And so we are going to be able to differentiate between directions, which is quite nice. Before they didn't have that. They just called it the Belgravia Strathcona or something like that. So we're going to need a new field that we're again going to denormalize. And this is just more of this cleanup. Trying to get the weird stuff out there. Like, there's a useless thing. If a bus is finishing one trip and it's beginning another trip, how do you know what bus we're dealing with? Basically, that's where this gets weird. And it's just installing the C++ aspects of MySQL. There's a MySQL C++ library, so I installed that. I need the curl, easy curl, and stuff for downloading. There's multiple ways to get data down. I could probably be using Pogo or something, that'd be nice, but sticking with just standard Linuxy stuff, we'll use curl. But back to this, we're now starting to figure out how to import, oh, here we go, protocol buffer stuff. So what we want to do is we want to figure out which of these. So sometimes we're updating because the bus was just finishing something, and sometimes most of the time we're inserting, and I want to see when we're doing that. So some of the time we're inserting. Right now I've got it always updating, but now there we go. Now it's inserting all the time, and then perfect. Now we have the data we're looking for. So now we need these head signs, they're called. Stop head sign, which is really the letters that are going to be on the bus. And there's no individual key, so I'm going to effectively create my own key and just count the head signs on my import. And one of the reasons I'm doing this, is creating a head sign table, is we don't want to be putting all that text into every row of the database. Both, I don't like text fields in an all integer or float table, and also why waste all that text repeated over and over again. And with 1.5 million rows in stop times, or 1 many million rows, I think it's 1.8 or 9 now, that would be a ridiculous waste of space to have the text, the head sign over and over again. So we'll just have a lookup table. So we want to insert and update the head sign codes as they come in. And as you can see, I keep jumping back, poking the Linux install to the next step. And then here, it's pretty straightforward, just like all the other ones. We'll store the head sign codes into the table, although this one, we're not getting it from a text file. We're sort of pulling it from here and there within another text file. And the head sign code, is very, very straightforward. It's I was wrong with my insert, and it's actually that I was just missing a %s. And I had this one using the old style, Python 2.7 style, iter items instead of the modern items, which is in Python 3. And there we go. So now it seems to be happily inserting those. And then we'll check the table, and there they are, all the head sign codes, and there's sort of 2 codes for each one, and then I've given it a primary key of my own. And we can use those later on. So there's the proto buffers on the C++, next step in that for its install. So now we need to start getting a website actually created on the Linux. Pretty straightforward. We're setting up effectively a LAMP server with the M standing for MariaDB. And we, yeah, so that's all. Go back to here. So now we need some details, and especially now that we have the head sign codes. So we're going to need to export those head sign codes with each of the things, because get the keys out. I think there's a function, array keys or something like that. I have to look that up later. Can do this, or get rid of my little for each. There's a way to do that. Again, switching languages so many times, I sort of sometimes forget the functions for any one language. Most languages now have excellent array functions, so same sort of functions are available, just all have different names. Rows by any other name is still a horribly named function. And yeah, so now we just get the head sign codes, build a table of head sign codes. And so now we need to import the head sign codes. And I've got the errors turned down on my PHP INI, so they might need to get cranked up. I'm not getting good error codes. I don't want errors all, because sometimes I like to assign values to dictionaries or associative arrays without initializing it, and that whines endlessly about that. Or I ask for values from a dictionary without that, so it says, oh, if you haven't initialized an associative array and you ask for a value, you're being an idiot. Whereas to me, that's just the way associative arrays should be used. They should have a default value. And anyway, so back to this, we're getting the head sign codes out. Of course, each arrival needs a head sign code. And then we'll bring this in from the JSON. We'll just store that lookup table inside the C data. We'll need a function for extracting the head sign code out. And since it's an array of objects, it's a little bit different than our array of just our standard array. And then here's a little getter for head sign codes, because here and there we're going to need to get the text out of it, given any head sign code. So here's where we'll put it in our details layer. Now you'll notice we still haven't done buses yet. Not worried about it, even though that's the primary purpose of this whole app. It's buses are not as big a deal. Stops are oddly enough the core of this entire thing. Everything revolves around stops. Stops are very much stops choose which buses we need to know about. They choose what the schedule is, so on and so forth. There we go. So now, based on the how long before the arrival, we're going to just create a series of different strings. These strings will be, like, just as you can see, relevant to it being potentially have left, being soon, being a long time, or potentially really it's right there. And make the text kind of friendly, informal. Sort of what your friend would answer if you asked them how long before the bus gets there. And you'll notice I put a certain amount of mights and shoulds. And that's because we're basing this on a schedule, and I think just about anyone who's ever used a public transit system knows that the schedule and reality are pretty well on different planets. This is not Switzerland. The buses do not run on time. Although, as more and more of their system becomes electronic and the public gets more and more access to what should be happening and what is happening, you can compare the two, then there might be more of an incentive for them to get this more and more right. Not to mention, if people like myself build them tools to help them anticipate problems, they will end up being more easily able to make their system right, rather than a bunch of humans trying to make a bunch of decisions. Automate it. No doubt, using a little bit of Bayesian statistics, you can actually figure out where the choke points are and start modeling it. I don't know, Markov chains for the modeling of how a bus system might look from day to day, using the probabilities that were extracted. So, just a guess, throwing that out there. Anyway, back to stop times. Now we're going to actually start looking at, I'm duplicating the import of the stop times. A more efficient way would be to do these two table buildings at once. But I'm looking at the data in such a different way for this second thing where we're creating the motions, that what I want to do, I'm just going to do it twice. Two separate runs at the data. This import routing data only happens, as I say, once every month or so. So I'd rather code simplicity over efficiency. So the goal of this motions table is that given any time, you can then know where in a trip a bus is. So rather than know a stop time or an arrive time, it's when did it's the time is a depart time. When did it depart for this motion? And when will it end this motion? So really I could call it, instead of depart time or arrive time, I could call it begin motion, end motion. And the idea is, given a time, we can ask given a time and a route, we can say where is a bus. And that will then tell us the motions of that bus. That is, because that's what we're doing. We're estimating it. But we also want to know where it left from, when it left from there, where it's going, and when it will arrive there, because then we can interpolate. Let's say the bus would take 10 minutes to go 1,000 feet. We know that every minute it goes 100 feet, very slow bus. And so 2 minutes later, we know it would be 200 feet between stop A and B, and we'd be able to interpolate that and figure it out. So anyway, here's where we're putting all the data out of the positions that we need for all this to work. And we're importing the first round of motions. Let's see how they look. And this is now where we start to talk about buses. Now, some of the fields I'm importing, like stop sequence and whatnot, I still haven't figured out what I'm going to do with the stop sequence. It strikes me as such a useful field that I'm importing it still, but some of these fields could probably go in the garbage. So we just make a duplicate of the bus class that we pulled out of PHP. And now the known is going to be some of these buses we're eventually going to be getting from the vehicle positions protocol buffer data that they feed out live. And that will kind of well, at first we'll just have two sets of buses. Known buses and unknown buses. Most of the buses will be unknown because they don't actually give GPS data for most of the buses. And then we will have a list of buses that are, well, we'll know their positions, and we'll identify them a bit differently. That way you can see when bus number 4 or whatever is coming your way, you'll know that is pretty well for certain your bus, and that's pretty well for certain where it is. Whereas we're going to be showing estimated bus positions, and those estimated bus positions are, well, the bus could be rolled over on fire in a ditch, and it would still be happily telling you that your bus should be there now. But so there'll be interpolated buses, or estimated buses, and there'll be real buses. We'll treat them separately, and that'll be what the known and unknown is about. So we just need to import the data from the JSON. Pretty straightforward, nothing too miraculous there. And then we're going to have, eventually we're going to need some more fields in there, but it's pretty straightforward. As I say, we're going to be doing interpolations of the data so that we can actually animate the buses as they move around, the estimated buses. And yeah, so I was importing the motions over and over again. Didn't need to do that, in that I wasn't truncating it between imports. It was causing duplicates. And now, as I say, a lot of the bus code is just duplication of the stop code. Once we built and perfected stops, that all passes on to buses. Buses are actually very straightforward to build. Not completely, we got labels and stuff that are different, and they rotate and do a few other things, but and the other thing with the stops, that was a great place to start with, is the stops are fixed in space, and I know a stop on the map makes perfect sense. Whereas if I'd been putting buses on the map, I don't know if they're in the right place or not. I don't know where buses are supposed to be at any given time. I have no feel for that. There should be a cluster of them southeast of me. That's about the only thing I could say. And even then, depending on the time of the day, the cluster may or may not be there. So now we're adding X, Y fields to the bus. Just like the stop, it will calculate coordinates. all the in-play type stuff needs to be duplicated. Again, that could probably be built into some kind of class or something. It'd be a bit more cleaner. And then the updated motions, it looks good. Now we're only importing motions for 327. And that looks good. Or looking at the motion, sorry, for 327. And some of the duplicate key stuff isn't really applicable because, again, we're looking at motions. It's a bit of a different arrangement. There we go. Buses are coming out of there, but we're not quite getting enough buses. So now this is a quickie radar click. And what we're going to do is just very straightforward, get the distance. And we'll use the location distance within. There's actually a vector distance thing, so why not use that rather than do my own hypotenuse code. And so now it selects a stop. So if we click, and then this is where we're starting to run into weird code that's inverted. So there we go. As I click all over the place, the nearest one that I'm clicking to is selected. Now I go with the nearest rather than clicking to trying to detect an individual sprite click. One, it decreases the complexity of the touch code, but two, when you're using your big fat finger on your iPhone screen, it makes it easier to do two things. One, a click will always have a satisfying result of clicking a fairly nearby stop. And also if two stops very much overlap, which is not uncommon, you can kind of click away from the stop that you want to select, and that makes it easier to fat thumb or fat finger select a stop. And that all just works better. And so now this is where, when the stop is selected, it actually rolls the table view up to the point of where the stop is. So when you click on the stop on the radar, that radar or the table below gets selected. So, and then scrolls up to there. At this speed, you don't quite see the scrolling properly. So now we need to look at the motions of the bus to figure out where something's going to be between any given two times. So you pick a time, and then it will give you where it is. Now it's possible that a bus is sitting. Sometimes with transfer, a bus will sit at a spot, so it isn't actually moving. But again, that's fine. We can interpolate nothing. The motion will be 0. That's a perfectly fine interpolation. The trip ID, as you can tell, is probably one of the most valuable quasi-unique keys, or it's one of the most important identifiers, but it's not perfect because the trip ID changes from one trip typically to the next. So as the bus goes from the last stop of a run to the first stop of the next run, the trip ID will change, when in fact it's quite potentially the same bus, plus let's say there's 50 stops on a route, so stop 50 is probably 100 feet from stop 1, yet it's on a different trip. So you need to really be able to identify that it came on a trip. It's en route. I mean, if it's 100 feet away, then it's probably a minute away. But being on a different trip can cause some weirdness in the way that you need to interpret now things that are on a rolling route. And it's not quite a perfect modulus kind of thing, because it could be the last trip of the day or the first trip of the day, in which case you don't, where's the bus coming from? It's not really coming from anywhere. And you then just are looking at an arrival time without really knowing where the bus is. You can like guess. So in those sort of things, we're going to be showing a bit of a fiction as to where a bus is. And array keys. Array keys is the function that I was thinking existed before. It gets rid of my having to cycle through the associative array, and we can just put it straight into the join rather than just get rid of these associative arrays. I knew there was a function for it. I had to look it up. It's one of those little things you just forget. And there's my favorite var dump, makes things nice and clean. We can see how things come out. So now we're looking for the list of routes so that we can get the head signs for just the routes we're talking about. Or, sorry, the yeah. So anyways, now we're looking for the motions for a collection of basically where is the bus now? What motion is it on? And we're not talking about motions 5 minutes ago or 90 minutes from now. We're looking for the exact time now, like given a specific time where, what motion is it doing, and then that gives us a start time, end time, destination, origin, latitude, longitude, and so on and so forth. And with that, we can know where a bus is. So now we need to turn the errors back on so I can see where my error is. And it was just I left some crap code there. Turn that off. And now we're getting motions. They're looking good. So now we just need to look at the data from the head signs and figure out why I'm not getting that right. There we go. There it is. I was zeroing it all out by accidentally leaving that other code there that I copy and pasted. So we're not going to interpolate first. We're just going to say you are where you end. And there we go. Buses are ending up at their stops. So even though they're en route to that stop, we're just showing it on that it has arrived, which isn't correct. Now let's get labels on these buses. So it's the same sort of thing. We're just going to put the label. And the reason the label is a separate icon, as I said before, from the bus is the labels won't rotate and the buses will. Buses will rotate in the direction that they're facing or heading or driving or whatever. And I'm using a bit of a misnomer here. I'm going to use heading and bearing. And I'm going to use one for which way it is from us and one for which way the bus is heading, like actually going in the direction. And if we were talking to some nautical navigator with his sextant in hand studying the stars, I suspect that my terminology would either be lucky by random chance or is flipped. But either way, those are the terms I'm going to use, heading and bearing. Now, as you can see, the C++ and whatnot that I'm using, I'm keeping it very simple, modern C++. Nothing too scary here. It's just code. Keeping my objects fairly simplistic. I could put in more error handling. That's probably a good idea, although a lot of the error handling, as you can see, I just give up if something's not working right. I'm going to increase the density of this background. So it's again a pastel type color because it is not critical. It's not something that you're acting upon. we'll get that lined up right. There we go, nice, nice big bus number, crammed right in. And instead of putting the bus number on a much larger sprite, there's concavities, which then means buses that overlap somewhat will still be visible. Whereas if they were a big sprite, you'd just barely maybe see an edge of a slightly overlapping bus, and you certainly wouldn't see what number it is or anything like that. There we go. So we zoom out, we see lots of buses. Of course, right now they're all heading north. So we rotate the buses to where they're actually heading, which is divined by figuring out what stop they were at, what stop they were going to, and the presumption of obviously buses turn, wiggle up and down roads, but the idea is we're only working on a stop-to-stop basis. It's as if someone paved all of Edmonton. In theory, I could use some kind of driving type database and actually create a series of sub-points, which would actually be pretty cool, where I would actually show them driving along the map based on the assumption that they drive the most logical route of the driving. So if I just continuously asked for directions from one stop to another and made the presumption that that was the route, then I'd probably get it right most of the time. Probably be better than having the buses driving down through buildings and over rivers. So now we need to go how far a bus is given a distance and time, or heading and time. Heading distance. Distance is determined from time. So there we go. We figured out the travel time was probably so far. How far could it have gone? And there we go. The buses are now moving, but this is only an estimation of their reality. It certainly doesn't reflect an actual reality unless the bus happens to be perfectly on schedule. Now that I realize the updates were happening too much, because when you modulus on a second, that second lasts for a whole second, which means I would get 30 moduluses equaling 0. So time now mod whatever comes out to 0 every time that the second, so let's say that we're using a 5-second interval, the modulus wasn't working out. So what we need to do is we need to say what only update once for any given second that happens to meet the interval. And that way we don't have 30 updates on the second of the interval, and then no updates on the other non-interval seconds. There we go. So bus seemed to be turning and going from stop to stop the way it should. So there's a little bit of herky-jerkiness. I think I've got some motion imports that aren't perfect. Now, one of the things that I will do is go out and actually see if the buses are doing their thing, like if the buses are actually like moving around as they should. So now let's import the live data. I'm going to look at doing this in C++ first because I don't know. One of the reasons is the protocol buffer. I'm probably going to use protocol buffers to replace the JSON output from the positions PHP. And that means that the iOS program and the Android program are going to need their own protocol buffer and import. So I thought I'd play with protocol buffers in C++, although I think for every line of code I write here in C++, I could write, for every probably 20 lines of code I could write in C++, I could write one line of PHP, or not PHP, Python for the import, and the bulk of the import delay is going to be the actual waiting for the data to come and waiting for the database to do its processing. And we're only looking at about 100, 200 rows of data. I think I was looking at the protocol buffer data, and there's about 190 buses at a peak being reported. So therefore, we don't, like, it's not that the C++ is going to bring much of an advantage. I mean, even if the C++ was 1,000 times faster than the Python, the actual time savings during an import, which will happen roughly once a minute, so again, not a huge drain on the server, we would be saving maybe 1/10 of a second or something on the server per import, which once a minute isn't really worth it for code simplicity. But as I say, I want to do this because there's going to end up being protocol buffers on the mobile end because the JSON is just too big. Someone sitting there waiting for their bus could use quite a bit of data over a period of time waiting for the while they wait for the bus. Let's say they've got a refresh time of once a minute. They wait 20 minutes for the bus, there'll be 20 refreshes. I don't know how much code there is there. 200K of stuff coming out of the JSON, and I could probably get that down to 20K, 50K. So I'd be reducing their code from somewhere maybe 1/5 or 1/10 of the size, like not by, but to. So here we are getting the, this is where we import the GTFS thing that we generated with Proto-C, and we're getting the entities coming in. There was 190 of them, and 191 of them, because it's always changing. And then we have to figure out from the Proto-C, or from the Proto file, the structure of the code. And I sort of was playing with this a little bit earlier, so I realized that the Edmonton transit feed is negligible, even though there's quite a bit of code that goes in a standard GTSF feed. We're just looking for the trip ID, the timestamp, the latitude, and the longitude. And a vehicle ID. There's an ID which is a vehicle ID. Seems to be unique to the vehicle, and the vehicle can change from one trip to another, which then translates potentially going from one route to another. So it's obviously certain vehicles have GPSs, and most vehicles don't. I don't know what the exact count is. Could work it out from comparing motions, and there we go. We're getting all of that. And then that trip ID, as I say, is fairly good. Although I made an interesting discovery, which is that sometimes the vehicle's reporting one trip ID that isn't actually happening at that moment. But we can still figure out the route ID somewhat. It's weird. So it's quite possible that I, from the schedule, will have a trip that is happening at one point, and I will estimate its position while there's an actual trip happening from the GPS. And they're both really the same bus happening at the same time on the same route, roughly in the same place, because it's roughly on schedule, and I've got garbage data. So now we want to connect to the database, so we can stuff this in. And it's very much like the Python connections. It's the same connection, of course, but we're also going to just do the same thing. We're going to truncate the table, import it, commit it, and be good. And because it's a commit on an INNODB form of a table, it means that it's a transactional thing. So there actually shouldn't be a moment in time when there are no vehicles. We will, because that would cause some weirdness. And it'd be actually interesting to store this data over time and start playing games to see what kind of patterns of buses moving around. Do they move around at the same time every day, and how they compare to the schedule? So then we could start making a probability. Is a certain bus going to be late? Because if it's late, say 2 o'clock every day, then we could eventually start just saying to someone, the new estimate, scheduled time is in 8 minutes, probable time is in 15 minutes. And if we were right a lot, people would like the software. They'd know that reality was having something to do with it. Anyway, so here we're importing the feed message, which is really just each bus. And then feed message is the overall message, and we're then looking for the feed entities, which are the buses. There's a bunch of other data which you can get from here, which is actually pretty cool, but they don't fill it out. Like there's like one that's basically translates to there's a riot on the bus. The bus is overcrowded. The bus isn't making stops anymore because there's too many people. All kinds of codes like that, but they don't seem to be using any of that data. So we're getting a bus, not that long. So even the timestamp is fairly useless. I guess it would tell us if the data is old somehow. But I guess in theory, if a timestamp just froze for a long, long time, we know that we're not getting updated information from a bus. That would be some valuable information. Now, I'm not expecting any MySQL errors. Again, we should have some logging and stuff because this is going to be an cron job. But really, if the database has gone down, we've got a big, big problem. And so there we go. So there's the vehicle data being imported quite nicely out of a huge pile of C++ code. I think I'm going to redo that in Python. Just that C++ code is ugly. I like C++, but there's certain things, especially when you're just manipulating data, where Python, it rules. I find the pairing of Python and C++ are an excellent, excellent pairing. What one does well, the other one doesn't necessarily do so well, and vice versa. So they really can hold each other's hand. Now in this case, I've just scaled up the known buses to make it much larger. I think we'll make the known buses green. And same thing, we need to align that up so that it rotates around that center point. And so we zoom out a bit. And so there's bus 327, that's the one that's always in my neighborhood. And the problem with 327 is I watched last night the vehicle position data bit, and it's never being reported. So it's the most relevant bus. It's the one I could step out the door and see if the GPS data makes any sense. And of course they don't have GPS on that bus. Although the route is so reliably boring. It's not a very high traffic route, so I can see why they wouldn't have put that high on their list. So now let's try the Python. We created the Python header, the import that we'll import there, the GTFS real-time PB2. And then look how easy it is. We're getting that request, dead easy. That processing the feed messages, dead easy. Printing them, it's, yeah. Yeah, so something's wrong when I take, what is that? Initially 14, 15 lines of code or 20 lines of code or something to do something that I did in the C++ in 1.5 billion lines of code. So yeah, Python is really good for this. Not to mention that I would say someone who was okay at C++ would probably, and never did Python in their lives before, would probably rather go into my Python import code and modify it than go into my C++ code, which is still not that complicated. So this is one little thing we need to do is in this positions is we need to know which trip translates to which route. So we actually have to pull data in from, just like we did with the C++, we have to pull data in from the database, which is just the route lookups. And then be able to create a nice insert, because as I say, I like to denormalize that data. I want the route right in the vehicle thing. I don't want to have to look that up. creating more complicated SQL, and that's SQL that's getting called quite frequently. So to denormalize what is, well, this is not really an occasional insert, but it's a 1 minute insert, whereas if there was, say, 1,000 people using this, that'd be 1,000 requests for every one insert, so I don't mind denormalizing. The database. Make it much more efficient, and again, the query is simpler. If I can have just a single select from a single table, I'd infinitely prefer that than even just one join, one subselect, or anything. Speed and efficiency and cleanliness. There we go, I'm just pasting in a fun little logo because I'm really putting, not finishing touches, but I feel that the code is approaching sort of version 1 maturity. Not version 2 maturity. Version 2 has got some serious changes. A lot more error handling, a lot more, there's probably some flaws. I'm probably just dropping some data or whatever. And a lot more error handling, a lot more, there's got to be some memory leaks in there. I remember typing the word new and I don't remember typing the word delete, so now let's create some icons. We'll go with the hand-drawn look initially. I might change it a bit. One thing with an icon is people are looking for something with an icon, so probably the smart thing, since people are always looking for a bus when using this app, I should probably have a bus in the center of this icon. But I'm going for quick, dirty, again, version 1. Version 2 will make it a bit more perfect. There's the wonderful expression, good is the enemy of, or great is the enemy of good, or perfect is the enemy of good enough. And I could spend 6 weeks developing this instead of 2 days. And there's all kinds of other features that can go in here. We can put advertisements in to make a revenue model. We can definitely, gamification should go in. I love gamification. Makes an app good. But there's a term people are loving these days, stickiness. So now I really should have sped this part up. We need to create 1 bajillion icons where for every conceivable size there's a required set, there's a recommended set, and my theory is I've had enough apps turned down because they would say such and such an icon's missing that was, I thought, in the recommended set, but they were like, no. So I just make all the icon sizes. And this is one of these things where they really need to just say, here's one size, put 1 or 2 sized icons in, and you're done. So now we need a background, and this is my first attempt at a background, but then I realized after I did it that it was going to be what do they call it? It was just going to be too large. All my backgrounds, they're full screen for huge resolutions, so my backgrounds were going to be megs and megs of background because of this blurriness. PNG does not like blurriness too much. I forget whether you can do a JPEG background. If I could have done JPEG background, that'd be better, I guess. But my backgrounds are PNGs, and they're huge. So I think the app installed prior to this is about 8 megs. And this was pushing it up to like 16, doubling the size of the apps because of the few backgrounds, maybe not doubling, but many megs were being added. So I rethought it and decided that, and this is just me copying the backgrounds into place, and these are the desktop icons. I'm not going to bother. I'm not going to put out a desktop version of this, at least for now. I could. They made it so you don't have to pay a separate fee for the desktop store. It's $100, of course, for the normal store. And So one of the things I realized is I would change the backgrounds to something that was more compressible through PNG. And so I went with a nice, simple black-ish. As I say, I don't like doing pure black. And this compresses to a fifth or eighth or something the size of the blurry one, because that Gaussian blur would drive PNG completely mad. And so this one is much, much smaller. I'm not even sure all those backgrounds come to a meg. Yeah, there we go, look, it's about half a meg for the whole pile. And then there's my icon. Hoping to be able to change the background. Can't seem to change the background on a simulator. So I looked at it on my background to see what the icon looked like, and it actually looks pretty good. It's kind of cool to see the weird icon that looks unlike most others, because it's got a weird, as I say, hand-drawn look, and everyone else's icons are so fantastically sharp, although I think I do need something a little more, a bit more pop. But I do like the hand-drawn look. It's fun. And so now, looking at the buses, everything seems to be moving, doing its thing. I'm not updating buses live, so of course I don't have a cron job running, so I'm not actually getting the live buses anymore. And we're getting fairly late at night, 9 p.m., and so bus routes are beginning to disappear. And I'm just starting to put to-dos. I like putting to-dos right in the code where I'm going to modify, and then I look for the uppercase to-do. I'm not working with a team of 50, so I don't need a centralized ticket system for versioning and planning out the next version of the software. And it just creates a nice situation for an app like this. I can just do a look through the to-dos. One search shows me them all. I pick one that's something that I'm happy to do right this moment, and then to do it. And it's actually nice. Sometimes I'll see some of these to-dos I've already done. So now this is where I saw that I wanted to do the pinch, and I think I've only said it about 6 times during this development, but the pinch involves multi-touch. So I need to go and get the multi-touches going. And touches in Cocos 2DX can be wonky. So we need to so I need to switch the touch from 1 to touches, plural. And there's a better way to do the callbacks rather than this kind of lambda thing, because the lambda is really just saying call another function. So why not just set the other function as the callback? And touches, of course, you get multiples coming in. And then we need to start playing this game where I get the touches going, multiple touches at a time, and I'm separating the touches so that there'll be sort of a touch event for the radar, there'll be a touch event for the zooms and other things like that, the menu. Sure, that's something I gotta do, the menu. There's a to-do. And I've got to make sure that one touch doesn't break another touch, because that is not uncommon, that one touch will break another touch. And then also, one thing I'm fixing is within the table, when I clicked and moved, it would then click on the thing. Like if I was just, all I wanted to do was drag the table, not click on the table. The first click of dragging it would select a cell. That's not necessarily what I wanted to do. So I need to create a while moving, ignore that sort of thing. And here's just a quickie bit of getting the buses so they're not animating and the stops aren't animating outside the radar. As you've been probably watching this whole development, they've been animating over the header, they've been animating all hiding underneath the table view, kind of ugly. Could be cool, could be a function, could be a feature. Could have them popping up and down, sort of as if they're playing a game of hide and seek, but anyway, so back to the touches. We need callbacks, we need plural touches. And we need to make sure that we don't break the touches, because breaking the touch, I don't know what kind of wonkiness it does in event handling in the back, some kind of signal slot system or something, I don't know. It goes weird when you start doing what I'm doing. And so getting everybody to cooperate can be a little bit of a game. And this is where the complexity of my not isolating the radar is starting to bite me. And I don't mind, I'll just isolate the radar soon. It's one of these things that I sort of saw it coming and hoped to avoid it, but here it is, and it's easily fixed. As I say, it's C++. These things are not super difficult to deal with. You always have pretty well an unlimited ability to either do things differently, use a different library, do it yourself. You're never committed to just doing it like some API's way or something like that. Or I shouldn't say never, but rarely. I certainly wouldn't want to do an end run on, say, the core location or something where you're trying to hack into the internals of the operating system or something in this highly sandboxed world. That would be a pain. So if core location were not to work the way I wanted it to, I could be actually quite doomed. But we're not. So things like that, if they don't work, then the phone's a failure. Now, one question some people might actually have while I do this rearranging of the touching, because I'm separating radar from everybody else, is why program it in C++? Something like this could have been easily programmed in Objective-C or Swift or whatever, and two of the reasons are portability. I like to be able to have this one set of code portable all over the place. I find compiling and running and testing on a desktop is a very, very fast part of the cycle. I'm running a Mac Pro, not a MacBook Pro, but a Mac Pro, pile of RAM, just ungodly processor in it and all that sort of stuff. And I find running the simulator is still on the slow end of things. So the time it takes to sort of spool up the simulator and whatnot is sufficiently slow that the extra time I gain by continuously compiling to the desktop is amazing. Now I could do that on the on Objective-C, but then the portability. I can now, I don't know what my total time to put this out for an Android is, but if I did the whole app here in 2 days, I can't see it being another day to get it all Androided up. And that's more, I'd probably be fighting with the Google Play Store more than anything else. It's not something I have done a lot, so that would probably be more the only end of fighting. And so then it's done. And again, and I don't know if you've ever developed a Android app, but the Android simulator, it's an emulator as opposed to a simulator. It's a simulator in iOS, and it's fairly fast. As I say, I complain about its speed, but it's fairly fast. Android uses an emulator, and again, on my machine, which is pretty bonkers machine, it's just brutally slow. So I don't want to develop straight for Android. That would just be a nightmare. So develop an iOS version, then an Android version using sort of an overlapping code base, terrible. This way, just C++ code, the Cocos code. Maybe I have to put a few if-defs here and there to isolate the core location, and that's about it. I mean, even the communications code is identical in the Cocos 2DX. It handles that HTTP request thing, works beautifully. And yeah, so I'm still here fighting with the new variation of my events. Really, I'm just figuring out who's clicking on what. It seems to be working. I've got the radar clicks working and the zoom clicks seem to be working and everything. So now it's time for pinch to zoom. So we kind of need to know when the pinch begins, although I find there's a weird situation where, again, this is one of these weird touch things. Sometimes I get a touch event that begins, and other times it just begins with a move event. Then to make it even weirder, touch end sometimes isn't fired, only the move event. It's all kind of weird. So you need to play a little game where pinch, the pinch, the zoom, everybody, they all just sort of work. Now, there is a view within Cocos 2DX where I could have the view change, scale in and out on its own. It does work very well, but one of the problems is my icons would then shrink. And so now this is just me testing to see what kind of data I'm getting in pinch to zoom in the simulator. The simulator has a limited pinch to zoom sort of capacity. And but yeah, so what I could zoom the whole thing, but then the icons would zoom in and out, and that would be bad because, of course, I'm already pushing the writing to its smallest that I can fit in there, the stop IDs, the bus IDs. So if I made them much smaller, they would be unreadable. I know I could play a game where the zoom goes in and out, and then I rescale the sprites. Be another game, but why not just feed that out into the data source? And so we're getting a little closer. So we're going to mark a distance, basically figuring out what the distance is between the 2 points, and then scaling according to the change in distances. So, and then those distances get changed over and over again. So I'm just testing this out on the actual iPhone. Can't see what I'm doing, but I'm moving things around. And then I realized I need to put error handling in here because we've crossed to 1247 and I'm running out of stops and stuff. So the data that started coming into my phone was crap. And it just sort of happened now. All the stops went dead, so there wasn't enough of a count in the positions. This is where unit testing would have caught things like that. But I'm not unit testing yet. In a way, this is a prototype. If I had a hard and fast design, then I might have done that. So anyway, so we store the distance between the 2 points on the pinch, calculate the two distances, and the beauty is the point has a built-in distance, so we don't need to again do our own trigonometry. And so we are going to figure out what the ratio of the change is. And so now we have a ratio, and then with that ratio we can set the scale. Now in previous pinch to zooms that I've done, one of the things that can happen is when you first put your fingers down, there is of course no scale difference, or just a third finger can come in and change the scale wildly. So what we'll need to do is we'll have to look we need to reject zero scales because they're a possibility, and we need to ignore significant changes of distance. So if there's a huge distance change, then we just sort of throw it out because it's unlikely the person moved their fingers really, really quickly, like so fast that, and then you can't really see the zooming going on my iPhone, but it was working quite nicely. It was very, very smooth. So we'll do this on the simulator. And so now the simulator, as you can see from the pinch to zoom, it's zooming in and out just as it should. And if you don't reject the spurious ones, like where third fingers come down or something like that, then, as I say, it'll be all herky-jerky. It'll zoom out by a factor of 8 when you only meant to go out 5% or something. So there we go, a nice smooth zoom. And then just make sure all the code is working as it should. Again, it's at what point do these different events take place? And as you can see from my data, there's all the buses have stopped coming. We still have stops, but we don't have buses really. Because it is now 1:21 in the morning. So what I'm going to do is make it a midday, midweek. And then we have data again. Now the only thing is the data resets, because every time it requests for new time, it gets the old time. So the buses just sort of jerk back and forth. So now we're starting to really, the core of the app is now done. There's a good rule in software development, and that is release, release, release. So I'm probably going to put a menu in, and a variation on the term release, release, release is, or deploy, 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 is put some perfume on this pig, or put some lipstick on this pig, and send it to market. So that is exactly what I think I'm going to do shortly. I'm just going to do a few little cleanups here where there's a few table cells and stuff that I want to make work a little better. So now when you click here, you can get I want that to be a selected thing. So depending on the cell that you've selected, we've got that selecting, just expected behavior. Again, we've got to do the same thing. It keeps jerking back to the wrong thing like the other one did. Now it doesn't. And so the touches work properly here. They don't work properly in the other one. A little terminology change there. As you can see, the buses are jerking back and forth, but as I say, that's a reset of the time. Every time it requests new data, it's getting the old time because I'm locking that time in. Time isn't moving forward on the server anymore, just temporarily. And then the same thing here. We want to make sure that the touches are working the way we expect them to. And there's a little bit of a weirdness that I've detected here where radar touches aren't quite working the way they're happening in another part. We don't need table and radar to really be blended, so I think it's probably a good idea to separate these two completely. Two separate listeners, two separate sets of functions, and two separate, so we'll have a whole set of functions that are fired off. All the callbacks for the radar will be separate from everybody else. And as I say, this is really a prelude to isolating radar as its own little class. Every moment I delay is really at this point in time just being a bit dumb, but it's 3 a.m. in the morning, and I don't want to. As you can see, there's been a few times when I stopped and often got something to eat, but development is largely progressed. I think there was one point where I accidentally recorded the wrong screen, so you got to watch emails come in for a while, so I deleted that. So a little bit of development got cut out here. But largely, to sort of wrap this up in a way, is this is very straightforward. You can develop just about anything once. With Cocos 2DX, it's of course a game environment, but this is kind of a businessy app. I would say the biggest weakness, if you want to call it that, of Cocos 2DX would be inputting a lot of data. The Objective-C, the basic UI sort of stuff that all comes with Cocos 2DX, it works very, very well with Objective-C and everything, and the UI is just better for text inputs and stuff. But if you just need someone to input their email and address or something like that, type a quickie text review or something, it's not too bad. And I think with, again, being C++, you could fight with it and make it do whatever you want. Now what I'm doing here is I want a selector. I want something to identify when you've selected a bus. Basically, you're trying to say where on the radar is the bus that's coming my way based on the head sign. What have I selected? And so I'm just jumping out of here for break and getting the Unix or the server working. And there we go. I've got it connecting so that we can now start uploading the the code. So we'll create a database. Nothing too unusual here. We log in. As I say, I created that one with a username of root. There's no other users. Very simple security. It's not a complicated thing. It's the virtual machine is it's behind my firewall, and it's also going to be gone within a day. So I sort of skipped a lot of the keeping things secure. Normally I wouldn't even SSH into a thing. I would SSH, but I'd use an RSA key all happily on my machine, so that then that key would have its own encryption, but not just using the password straight in. And so now I just zipped it up, moved all the code over, and then here is some code, and I think that's a bit that I missed. Forgot to turn it on after I was finished eating, where we have a selector. So when we select a thing, it will, yeah, I missed that, where I drew the selector. And then began its rotating code. So when you select a route, it will show you the buses. It'll highlight them. And pretty straightforward. You just click on a route, and there's the highlighted route. So it's like, answers the question, where is my bus? It's potentially the bus with the spinning orange thing. And as I say, I might change the highlights of some of the other things to orange, so that orange would just become the universal highlight color. Of course, we need to identify what the app is continuously while it's running. And just as I'm looking at this, I think the white on black actually looked better than the black on the white around it. It's more subtle, but I don't think subtle is always called for. So now we have I realized there's an interesting mistake, and that is that a bus that has just left is being marked as having 0 arrival time, which means it's there, even though it may have just left. So a bus could be up to a minute away, or half a minute away, being rounded to 0. So I'm basically saying if the time in seconds really is anything less than 0, then the bus is left. So that way we know that so here's just some to-dos going in. And potentially before I release the app, I might do a couple of these to-dos, but there's not much left. The app is fundamentally working. While I do the final wrapping up of getting things over onto the virtual server, which eventually, of course, will go on to a real server in a much more secure fashion, I thought I would talk about unit testing. Now, this app somewhat exceeds the complexity level that you can really achieve without doing unit testing, so unit testing is probably the next thing I'm going to do. Because as the project becomes more and more complex, the lack of unit testing will circle around and bite you on the ass. And I did actually quite a good video, I think, on unit testing within the Cocos 2DX GUI environment, because testing a game GUI can be quite difficult just in playing with the game loop and whatnot. It can be painful. So here we have it working with the server. Just have to install the proper version of the protocol buffer for Python on the server, and there we go. It's getting positions. Now it's 3 in the morning, so it's not many positions to be had. But there it is. It's talking to a Linux server. It's no longer talking to the desktop, and all is working. So this has been quite a journey. Thank you for watching this long. All the usual: subscribe, vote, comment, questions I'll answer, and good night.